I think we're at the stage where we're realizing
Yeah.
as humanity that we have such a huge footprint on the planet that we are now responsible for managing the planet. And it's
Mm-hmm.
not like we're the victims of the planet's processes. We are really controlling a lot of their
Mm-hmm.
processes, so of the planet. So that's like the entry into why we need all of this. And then once you realize that, wow, we really are managing the planet's future, then you need technology to help you do that. And whether it's a
Mm-hmm.
coral reef or a tropical forest or an agricultural field, knowing what you've got, understanding its condition is just foundational to making a
Absolutely.
decision. It's
Mm-hmm.
not going to be the answer to all of it all, but you won't make the right decision unless you know what you've got.
Absolutely. Yeah. Yeah.
Hi, I'm Rajnish.
And I'm Brigid,
Welcome to Terra Science.
the podcast where reality matters.
Well, Bridget, today we have an amazing guest. This is Greg Asner, and Greg is the director of ASU's for Global Discovery and Conservation Science, which he started in 2019. And I've known Greg for about 10 years. We were both together at Carnegie Institution for Science at Stanford University. And I've been working with Greg on a project which we will talk about. But before we get into that, I just wanted to give a quick introduction to Greg. Uh, Basically, Greg has been known to map forests using airplanes and satellites. But he's not only done that, he's developed new technologies to gather data, large scale data, like biodiversity, carbon emissions, coral reefs. It's really amazing. These kinds of things that we think about and see. Well, how do people study global level? What happens? That's what Greg has done, and I think it's truly remarkable. So, Greg, would you like to say a few things about yourself?
Well, thanks for having me. This is fun. Yeah, I have been mapping the planet for quite a long time now, in forests and coral reefs, and you name it. We've had lots of opportunities to contribute, and I think the satellite mapping and the aircraft mapping we'll talk about are contributions to a larger problem of trying to understand exactly what's going on our planet and how we can manage it better into the future.
One of the projects that we've been working together on for about 4 to 5 years, Greg developed what we call CLASlite, and it stands for Carnegie Landsat Analysis System, and that's the bigger version. But then that was Class, and the CLASlite is the lighter version, so that anyone can use it. And not only that, he developed this software which utilizes satellite images to map and to monitor forests at large scale, but he made it very easy for anyone to use with a course. So, Greg, if you can tell us what makes ClassLite unique from all the other, because there are other methods, including infrared, and what makes it unique and how it can be applied both forest and agricultural applications.
Yeah, like you said, ClassLite is kind of a light version of the old class system, which is really its birth. Its earliest days are 1997, 1998, and you have to understand how it works. You have to kind of go back in time and say, okay, we had these satellite images coming to us in the late 90s, and you could look at them and see that there's a forest in front of you on the image, but analyzing it to get percentages of how much forest cover is present, how much has been lost, those kinds of things, it was always a challenge. So way back then we started developing methods using satellite imagery, and by 2005 it was called CLASS, the Carnegie Landsat Analysis System, and it ran on a supercomputer. We mapped the Brazilian Amazon, for example. We had a
Wow.
lot of discoveries that occurred about humanity's interactions with forests in general.
Gold mines, was that it? Right?
That came later. Actually, early on, it
Okay.
was logging, selective
Oh,
logging.
okay.
Wow.
Okay.
Yeah, and so and I guess the breakthrough in that method was that when you look down on a forest from an airplane or in a satellite image and you see a big clear cut, that's kind of easy to see, and that was understood pretty well. What Class and now ClassLite can do is see the really fine scale, almost to the naked eye, almost invisible changes that occur in forests from other types of human activities, such as selective logging, taking out certain, mahogany trees, taking out bits and pieces of the forest in a way that it's a little tough to see with the naked eye, but the software allows you to bring it to life and to see it.
Wow.
When we did it in 2005, we basically doubled the amount of forest loss that was occurring in Brazil just by seeing
Wow.
all this fine scale stuff that was being
Right.
missed. And that's the essence of that software package. And today, yeah, I mean, it's evolved even more. CLASlite, you're right, about 2000 and I can't remember, but something like 2010, decided that we needed to move it away from supercomputers and experts and provide it to managers, conservationists, policy development offices, other scientists, academics. So we wanted to generate a broader user community. And so CLASlite was invented. And we went through a lot of work to try to, whittle this thing down to something that you can just run on your laptop. And it does today. And it's quite easy to do that. And now, because of that, the applications of CLASlite really exploded. They went from these forests that I was interested in and those were tropical forests, to other kinds of forests of all kinds around the planet, other types of ecosystems, including agriculture. And so CLASlite now has a broader base that applies to many different types of settings.
Yes, and we have been applying it in agriculture with really very um, successful results in monitoring what happens after, for example, an orchard is treated with an amendment, and so we can see how actually the green cover changes in response to something like that. It's truly amazing at large scale.
Yeah, I think it gives us a sense for not only our role in changes on the Earth's surface, but also kind of the natural, I almost said algorithms, the natural rhythms of the planet's biology is kind of also expressed in the CLASlite output. So it's a fun tool. Once you learn it, you can really cruise around the planet and explore places ecologically. And so I think that's been part of the academic use of it over the years as well.
Right. And now we have expanded it. So now we can also offer it as a service. So if somebody just wants to know what's going on in their orchard, we can run the ClassLight for them as well.
Yeah. And for the course, how long does it take for you to learn how to use it? Is it a simple course to take, or can anybody really do it as well?
I think you have to have a basic computer skills, and you have to be, I would say, seriously interested in spatial information,
Gotcha.
and then you can learn it. And it's not weeks of learning; it's days of
Oh,
learning.
Well, from ClassLight, how about we switch a little bit towards water? I remember there was a Discovery Channel, I think it was, right? The and you were part of that episode. It was called
Yeah,
H2O.
yeah. What do you want to know? Water. The planet is mostly covered in water. So,
Yeah.
we're
mhm.
sitting here working on this severely difficult problem of land issues. But, I actually started out in water when I was really young in the science world, 1992 or three. Worked in water settings, and then I got busy on land, and then some years ago I went back to the water and
Mhm.
have been working on different techniques, different approaches using aircraft and satellites to do three things about water. One is the water quality, what's in the water itself.
Yeah.
A second one is what's below the water, like coral
Mhm.
reefs. And the third one is what is uh, the amount of water in certain land units, like
Mm.
lakes and rivers and stuff that humans depend on. And that one is a newer one, but I've been working on that as well. So water, yeah, water everywhere. And so we've expanded, and I'm happy to tell you about any of those.
Well, so one
Yeah.
thing that comes to mind is, it's everywhere, but we always hear about droughts, and so perhaps it's not where we want it to be, in the amounts that we want it to be. So that people think has to do with human activity again, and so I was wondering what you think of that.
Yeah, that's true. The partitioning of water on the planet, whether it's in the atmosphere, in rivers, lakes, and ocean basins, etc., or in locked up in ice. All
Yeah.
three of those are
Mhm.
changing really rapidly on the planet, and I think humans are. They are. We know we've driven this through our greenhouse gas emissions and some severe disruptions in our climate system. but now we're kind of the recipients of this redistribution of
Right.
water. And so,
Hmm.
what are the technologies that let us understand what's happening and also to forecast what will happen next? And drought is one that's really important. We started working on drought in 2012.
Uh-huh.
It got mainstream for us, kind of science, academic mainstream by about 2015. And it's still not totally out there like CLASlite is. It's
Mhm.
not like
Right.
everybody can look at water change, but the drought issue is significant. And whether you're managing croplands or a forest, the newest technology that we have on board our aircraft, and I can tell you about what we're launching into orbit.
Oh.
But the newest technology on board our aircraft lets us really quantify how much water is in the vegetation.
Oh, wow. That's quite impressive. So like moisture,
Hmm.
uh,
Yeah.
Hmm.
that's amazing.
And is that just applicable to, forestry as well? But are you using that also for agricultural purposes?
We are. So I
Wow.
just came back from a mission 3 or 4 days ago where we're doing that in Florida. How much?
Okay.
What's the condition of croplands in Florida at this time
Hmm.
of year in these, X, Y, and Z crop species,
Right.
based on A, B, and C management, trying to figure out the matrix of human and natural and and climatological conditions that are generating high productivity yields in crops, low, and drought is one that
Hmm.
farmers are not. Uh, there are challenges,
Hmm.
big
Right.
time, and so the newest technology allows us to literally quantify the amount of water in the foliage and in the plant. For some plants, the entire above ground portion of the plant,
Oh.
and
Yeah.
that's really giving us a view into these plants as to are they starting to teeter, are they
Mhm.
is the if it's agriculture it would mean a management intervention like water the plants, but even
Right.
that is not as easy anymore as it used to be, not only
Right.
because of water availability but the management of water among farmers is a highly contentious issue.
Yes.
Diversions, it's not just water your plants, it's a much more complicated
Hmm.
landscape than that.
Right. And also directly links to crop health as well. So you were talking about you're going to tell us something about the satellite as well. Is that a different thing than this?
Yeah, well, it's no secret anymore, but I'm serving as the chief science officer for a new pair of satellites that we're launching in September of 2023.
Wow.
Okay.
Literally, these satellites are copies of the technology that's in the back of my aircraft, and the quality and instrumentation, the composition and quality of the instrumentation in my aircraft really is unique. And we haven't been able to make more airplanes and more of these instruments on aircraft. It's
Hmm.
just very difficult to create. So we said, well, let's go to orbit. Let's put one
Right.
up or two up in this case for
Wow.
everyone to use, rather
Great.
than me running
Wow.
around in an airplane.
Yeah.
And we'll have the plane because the plane's
Yeah.
needed. But
Yeah.
it's the mission is called Carbon Mapper.
Hmm.
Okay.
And you might say, okay, that's about carbon. Actually, the technology also serves a wide variety of issues. It's just that a primary mission for the mission is carbon. However, it sees the water content in the plants, it sees nutrients
Wow.
in the plants, it sees coral reefs below the ocean, it sees the quality
Wow.
of the water. And
Yeah.
so Carbon Mapper is kind of a misnomer. It's got a wide range of application.
So it's
That's.
literally maps the living or organic surface of
Hmm.
the globe. So that's the carbon mapper maybe link to it.
That's correct. So the technology is called imaging spectroscopy. It sounds awfully technical, I know, but it is a unique capability that has not been operationalized in Earth orbit prior to now. We're going to
Okay.
make it operational in September 2023. And the imaging spectroscopy is a type of remote sensing that sees the molecular composition of something. You point the instrument at plants and you see not all of the molecules in the plant, but some really important ones. For
Hmm.
example, the water content, H2O,
Mhm.
that's a molecule.
Hmm.
And so
Mhm.
it actually sees the H2O molecules through a mechanism that has to do with the spectroscopy. And spectroscopy is a technical term for how molecules interact with sunlight.
Mhm.
And so the entire technology is based on the fact that sun is shining down on plants, say, if that's your interest, and the molecules in those plants are actually reacting to the sunlight, and this instrument sees that reaction,
Wow.
and we're able to quantify how much water, molecules that have nitrogen in them, like protein and chlorophyll, any of these molecules that interact with sunlight, that undertake an interaction with sunlight. I'm trying not to be too technical. The instrumentation can see that interaction,
No,
and
no,
from that
that's great.
quantify
So
it.
I mean,
Yeah.
even nutritional values. So if you go to anthocyanins or other pigments or antioxidants, I think that's possible as well. Then,
Yeah,
uh,
I think you're right. If the instrumentation, if the spectrometer is high enough quality,
right.
and in the past, I was on a mission, satellite NASA mission in 1999, where we put one of these up in orbit, but it wasn't a really high quality instrument. It was kind of a first try instrument, and it didn't have the signal. It didn't provide the
Hmm.
details well enough, so we couldn't get to those antioxidants. But with the right kind of instrument in orbit, there's a lot more possibility. And
Hmm.
so, yeah, I think this instrument will map nitrogen, for example, quite readily. For example,
Wow.
yeah.
So another thing you used to, I've seen a TED talk as well on this, and anyone can look it up. There was getting species level information, like in a forest. What are the different species of trees, and almost like a three-dimensional image of even the height of the trees. So sounds like that is also incorporated in this.
It is the same technology that's been in my plane, and so it's a really cool thing because you remote sensing is no longer just looking down and making maps. It's understanding the biology, the evolution, the origins of different plant properties. And so
Hmm.
the biodiversity story is one that I think I'm most well known for. And what I asked is, um, are if you fly over a forest
Mhm.
canopy and you map its molecular composition, the way I just said,
Right.
are those molecular compositions of tree A versus tree B versus tree C, are they all similar, or are they different
With
by
species. Yeah.
Hmm.
species, or what we say taxonomically, right? And so,
Right.
and it turned out in the Brazilian Amazon, or not the Brazilian Amazon, in the Peruvian Amazon, that 80% of the time, the different molecular compositions that we're mapping from the air were different species.
Wow. Yeah.
They're like
Wow.
signatures. Like, you sign your
Yeah.
name, we know it's you.
Yeah.
Species
Wow.
do that molecularly or chemically, and so I got real excited, and a lot of my work. That's why I left the ocean for so long. I was really focused on that thing. Wow, we can map biodiversity, and had a you
Yeah.
know really major scientific breakthroughs that are, I think, help pave the.
And didn't this, if I remember, didn't this work lead to a significant investment in Peru? Uh, uh, I think there was, right. There was something like that. Yeah.
In that case, Peru invested a huge amount so we mapped all of the Peruvian and Amazon and Andes, the
Right.
mountain chain that's right next to the Amazon, and then the Amazon area, huge area, massive area. It took us a few years, and in that mapping, we discovered entirely new communities of trees that
Hmm.
were not unknown to locals, but unknown to the government's management programs. And so, there's a big difference there. And so back in Lima, they said, wow, we have uh, this whole area that isn't in our protected area network. So they created a new national park that included data from our this biodiversity mapping. And then we were taken to Borneo. Same thing. The Malaysian government took us over there to do a new 400,000 hectare. It's about a 1,000,000 acre uh, reserve or forest national park type of activity. And so we've been all around the planet doing this biodiversity
Wow.
mapping for
Yeah.
that purpose.
Right. Yeah. No, I remember. I think one time I called you and you were on some remote island, and I said, "What are you doing there?" So, global ecology.
Yeah, yeah, yeah.
That's
It's
amazing.
global ecology is global.
Right.
And the corals are the same story.
Right.
We figured out we can't do it as easily because seawater is so absorptive
Hmm.
that it's like really hard to see through seawater. But we're getting to the point now where we can map different groups of coral species.
Right. And so do
So,
you do
so
most of your coral mapping in Hawaii? I know that's where you live, right? Or where do you usually
I'm
go?
from Hawaii, and I do a lot. We've created the system here, but I have mapped now in Southeast Asia, Asian reefs,
Wow.
Caribbean, all over the Caribbean, from Belize to Dominican Republic, Virgin Islands. I just got back from Florida. I did the Florida Keys.
Wow.
I'm going around doing this. Again, it's for specific management related questions in those places today, but literally the same instrumentation I'm putting up with the team into orbit
Good.
in
Yeah.
fall of
And all of
2020.
this is being gathered into the Allen Coral Atlas, which is publicly available, right? Is that correct?
Yeah, right. So you can go to, so the Allen Coral Atlas is a project that I direct that is the world's largest coral reef monitoring system. And it's a cousin to all this. It's confusing for people to hear about all these programs and projects that we run, but that is where all of the coral reef monitoring ends up ultimately.
Okay.
Yeah. Right now, if you go on there, it is free. It's allencoralatlas.org. If you go on there, you can, for free, download data, look at reefs. You can see where
Wow.
coral reefs are. The big breakthrough that'll happen in 2023 will be how much coral cover is there? Is it living or is it a dead reef? And unfortunately, we have a huge range of answers to that.
So on that side too, what are some of those like interventions that you want to highlight, especially for not just coral but also carbon mapping and the biodiversity as well?
Good question. Yeah.
I think we're at the stage where we're realizing as humanity that we have such a huge footprint on the planet that we are now responsible for managing the planet. And it's not like we're the victims of the planet's processes. We are really controlling a lot of their processes. So of the planet. So that's like the entry into why we need all of this. And then once you realize that, wow, we really are managing the planet's future, then you need technology to help you do that. And whether it's a coral reef or a tropical forest or an agricultural field, knowing what you've got, understanding its condition is just foundational to making a decision. It's not going to be the answer to all of it all, but you won't make the right decision unless you know what you've got.
Absolutely, yeah.
So
that's so true.
We're trying to work at the foundation level.
Yeah.
And but then that information, that data has to be managed or interpreted in the right way as well, and then legislation or whatever action needs to be taken has to be also directed with the focus of making a positive change, locally as well as globally. That's the harder part. uh, I'm sure you must have heard Sadhguru, who's the founder of Isha Foundation. He's doing this motorcycle ride from London to India, 100 days, and I think his main objective has been to promote awareness of soil health and have people talk about soil health so they can make an impact in future legislation. And so what do you think, what kind of things can people actually, because there is a lot of information, and what I like about information is that anyone can get as much of it as they want. They can get really deep or they can get some higher level, but then where they get the higher level and correct information is always shifting. And I think you've already contributed a lot in a way to bring awareness and through social media, and I know your lab is very active on there as well. But what can we look towards the future in educating people more about what they can do and what is it that they can do?
Yeah, it's an interesting question, and I'm finding at my stage and age in my career that that's the question I ask every day. And it's awareness is important, and we need more of that, and people need to be doing that. But I think that this high resolution monitoring that I represent, it provides specificity to what people can do rather than saying, save the coral reef. It's like, okay, how do you do that? Like, I haven't heard someone say, no, don't save the coral reef. Most people agree that that's something worth having on the planet. They want specificity. And so a good example, just one example, is that, in our work, we're finding that what people do on land, up to hundreds of kilometers inland of a reef, of the shoreline, really affects the health of these corals and
Wow.
these habitats. It's not sort of an esoteric, cartoonish sort of understanding. It's real detailed. And so it's gotten to the point now where we can track a chemical pollutant source, like from households, into reef systems and say, guys, we're tracking this. It's killing these corals. Please reduce the use of X, Y, or Z product. It's getting to that so that people have real specific interventions they can participate in. That's the future of Earth observing. It's high resolution, but it's also it's high resolution, like the pixels are very detailed, but it's high resolution in the sense of the information that it provides.
Good. Yeah.
It can be down to different chemical products.
And that's really what's needed. I think but making people aware of the problem, but then also specifically the solutions.
Yeah.
That's
And
really
it can't be impossible solutions. They can't be these bars that no one's going to achieve, you or me or anyone else. It's got to be stuff that you can do. And then that also tells you what you don't have to do. Like, we don't have to worry about something X, but this thing Y, we're seeing it is getting into the reef system from 50 to 100 kilometers inland. Please, let's get that off the market.
Right.
And then it becomes like, I've had this happening, that then it becomes like a thing between science, management, taking care of the planet, and certain aspects of the commercial world, and certain companies hear that their product is killing reef. There's pushback. Then you have to have evidence. Again, the remote sensing is evidence, and it's admissible in court. I mean, I have had to do that over and over again.
Wow.
Yeah.
And what I like about that is that it can also have regional impacts, because there are different issues regionally. And so this specificity can really provide better answers. So not everyone doesn't have to do the recycling the same way.
Exactly. And the other thing is that big business, we all depend on it. It's, it's part of our world. But, people can have a bigger effect on how businesses take care of the planet by knowing the specificity of our footprint. It's kind of like here in Hawaii, detailed data came out that certain sunscreens were killing corals.
Right.
And the state of Hawaii was the first state in the US to ban certain sunscreens. It didn't say no sunscreen in Hawaii, you're all going to get skin cancer. It said no, these, and there are specific chemicals that were found to be killing reef. And now they're banned from Hawaii. And there was pushback from industry. But in the end, industry is going to want coral reefs to be alive too, because that's why people are coming here and buying their sunscreen. So
exactly.
Yeah, it's all part of the same supply chain and circular economy that we have to push towards.
But all I can say is that we need a lot more of that. We need a lot more of that specificity. Yes.
Yeah.
Fast.
Yeah. So that's super exciting. I have one question for you, Greg. I want to know what drives you. Like, what do you get up in the morning to feel so, driven? Because you've done so many important things in lots of different realms.
I've been lucky to see a lot of the world.
Yeah.
137 countries. There was like this lab thing that they had for me some years ago. 137 countries. I was like,
wow.
I did? And so,
wow.
But I've been who gets to do that? And so and so the two things that motivate me are the beauty of our environment and the uniqueness of our planet, of course, but also the people I've met and the fact that people do want to play a stewardship role. They do. I haven't heard someone say, no, I want to pollute the planet. It's kind of like the tragedy of the commons takes over. And so I see a lot of potential to change the course with the kind of information that we're generating. It's just part of the foundation of the answer. So that motivates me. Yeah. We're going strong.
Amazing. And that's kind of also, what we want to try to do with Terra Science is just get more of it out there, share your knowledge, and, hopefully interest more people in learning the specifics and what they can do and all of that. So really appreciate it.
No, thank you. You guys are critical. The communication, I mean, where would we be without folks like you? So yes, it's going to take this village to get not just the awareness, but the interaction with the right kind of solutions and outcomes and people actually playing their role.
Well, thank you, Greg. This was really amazing. We covered a lot of ground very quickly.
All right. Really a pleasure. Thank you so much for having me.
Thanks again for watching. You can find us on Spotify, Apple, Google Podcasts, and also the video format will be on YouTube as well. And I do want to shout out Riverside.fm. That is the podcast recording studio that we are using, and it is a really great format because you can separate out the audio and video files for each member, wherever they're zooming from or joining the meeting from. So it really helps with increasing the quality of each clip. So there's going to be a link in the bio as well for you guys to check out Riverside.fm if you're interested and have any purpose of using it yourself. And lastly, thank you again to Greg for joining us for today's podcast. We will definitely link down below some of the work to his project. So thanks again. Hope you guys have a fantastic day, and don't forget to like and subscribe.